My name is Kristy Zukswert, and my project is on, I'm a bio major, by the way, senior graduating very soon, like all of you. My project's on the STEM undergraduate learning experiences in Boston University's biology lab courses. And my advisor is Dr. Catherine Spelios. I think she's somewhere in the audience. There she is, yep. And before I continue, just a clarification, STEM is a nationally recognized acronym for the science, technology, engineering, and mathematics fields. So my overall objective for this project was to capture the STEM undergraduates' learning experiences in 3 of Boston University's biology labs: an introductory lab course, Bio 107, an intermediate one, Systems Physiology, and a more advanced lab, Biochemistry 1. From there, after talking to students and analyzing results from an online survey, I then isolated a unifying learning phenomenon in each of these, and then develop theories to explain such experiences. So before I continue, here's a little insight look at the 3 labs that students use. The top left is the introductory course, the bottom middle one is the systems physiology, and the top right is biochemistry. Notice the top left is a little more rudimentary for the introductory course, and the top right is more advanced with more equipment corresponding to the more lab techniques you'd be learning about. The reason why I chose these 3 courses was to include as many STEM undergraduates as possible, because then you can understand experiences from the introductory level up until the advanced, including sophomore, juniors, and seniors. So the motivation, though, behind this project is that nationally we are in a shortage of STEM professionals, despite the huge growth in industry and jobs that are available. This problem is known as the STEM leaky pipeline, and though the government made an incentive many years ago to graduate 1 million STEM undergraduates by 2018, we are not going to make that goal. So really, we really need to focus on how students are learning so we can fix this problem. So the President's Council of Advisors on STEM and Technology found one of the leading reasons why students are not continuing their STEM studies is because their introductory lab courses are dull and non-stimulating. So the University of Colorado Boulder took this into their own hands and really started looking at how students are learning, what are they learning, how could we improve these lab courses. So with that in mind, I wanted to do the same thing here at BU. So I looked at those 3 aforementioned courses and isolated some unifying learning experiences and determined whether or not they were positive, neutral, or negative. So before I continue, I'm defining these learning experiences as one element or factor driving students' experiences, and then in the context of it being negative, neutral, or positive, to culminate in an overall experience. The process was a qualitative study broken into an online survey in which I got 252 student responses. From then, that data was coded, and then I ultimately generated a list of the most frequently talked about topics in these lab courses. Likewise, I did student interviews, 13 individual ones. Students either talked about one course or in some cases 2 or all 3. From there, again, I tabulated the most frequently talked about topics, and these topics are what I determined to be the top factors driving their experiences. From there, I looked at whether or not, again, it was neutral, negative, or positive, culminating in isolated learning experiences. So a recap of that: what are these experiences? What are the factors that are driving them? Are they positive, neutral, or negative? So in the upcoming slides, you'll see the results. For the purpose of visualization, the neutral and positive results are categorized together in comparison to the negative ones, just to weed out kind of what really are the negative components of this, which is more useful also when you're hoping to improve a course. So for here, for Bio 107, on the x-axis, you'll see the top 6 things that students talked about, the top 6 factors, and then divided below that are the interviewee and survey responses. The y-axis shows the relative frequency of them being deemed neutral, positive, or negative. So for Bio 107, the driving factor of the experience was students teaching fellows, which students found to be overall positive or neutral. Similarly, for Bio 315, the same 6 factors are included because, again, those are the 6 factors that students collectively talked about the most over the course of the 3 classes. In this case, time was the leading factor determining students' experiences and was overall found to be negatively contributing to such experiences. Finally, for 421, the biochemistry course, this one was extremely variable. It was neck and neck with 3 different factors. So I included all 3. And they included the teaching fellow, time, and grading. The teaching fellow, believe it or not, had both positive and negative impact on students' experiences. It was extremely variable. The time element was overall positive, and grading was extremely negative. So what exactly were students talking about? Okay, so we know they're positive or neutral or negative, but what exactly does that mean? So after looking at the open-ended responses again of the surveys and listening to student interviews, for Bio 107, teaching fellows were overall positively impacting students' experiences because they were approachable, they were helpful. The neutral part of this is sometimes the feedback was not always sufficient, but again, that's to be expected. For systems physiology, the overall finding was that time was a negative influence on the experience. There was a lack of time. Because of this, students felt extremely stressed out and anxious in lab every week. They felt rushed, and unfortunately, students believed that their work was compromised. They were focused on completing lab reports as opposed to producing a high-quality report. So finally, for biochemistry, we see both the positive and negative influences of the teaching fellow. They are extremely variable in their level of approachability. The female happened to be more approachable than the male. The male, on more than one account, was called condescending and had a horrible demeanor and impacted one interview very much so. That was a very touching story for that one. Level feedback was also variable. However, all the teaching fellows seemed to be readily available. For time proved to be positive or neutral impact. Students did not feel rushed and could finish their experiments in ample time. And finally, grading. Grading was extremely arbitrary, students believed. They wanted the teaching fellows to have a more universal grading rubric. They believed that there was variability in the explanations where points were deducted, or in some cases, no explanation at all. Finally, their comportment grade, which is a grade that marks students' progress midway through the semester as well as at the end. They believed that that needed to be restructured because it wasn't grading students fairly. So, where does that bring me? 2 things, because I do have a few minutes. Subsequent studies of student demographics was also looked at, and I'll go into it later if you have questions about it. But there was a significant difference in the way pre-med undergraduates responded to these questions, as well as researchers, undergraduate researchers, and undergraduate tutors. Thank you. With that being said, student demographics, students come in with different experiences, and that really plays a role in how they overall experience and progress in a class, so it's something to consider. However, what are these final theories? So I talked about grading, I talked about time, and I talked about the teaching fellow. I ended up theorizing that 1, if a lab teaching fellow is approachable and competent in providing substantial feedback, he or she can positively impact the lab learning experience. Secondly, if students are provided with sufficient time to complete a lab experiment, students may experience significantly less feelings of stress and anxiety, as well as expend more energy on producing a high-quality piece of work as opposed to focusing on the completion of it. And third and finally, if grading protocol is universal among course graders and grading is clearly explained and justified, it can diminish frustration among students and positively impact the lab learning experience. Though these may sound like general theories, they're extremely applicable when you're considering redesigning and improving a course. And more importantly, these are reflections of how students are actually experiencing these labs and are learning. With that being said, I hope that these findings can be used to improve Boston University's biology labs, and also will be one step closer into fixing the STEM leaky pipeline problem. So, thank you very much. I do have time for a couple questions if anyone. Max.
So I know a lot of the teaching fellows are required as part of their fellowships to be a TA. So how do you have any suggestions on sort of taking into account that a lot of fellows are mandatory, they're required to, but you only want the good ones also?
Right, and I think that's something that every course is going to struggle with, because that varies on an individual level. Some teaching fellows are here for their graduate work alone. They want to be those researchers. They want to get their research done. That's all they care about. So yeah, sometimes that teaching component is the worst part of their experience when they're pursuing their doctorate studies or master's. So for that, I guess, it's just, we have to constantly remind those graduate students that that's part of their work in becoming better researchers. They need to be able to explain their findings to any population of students, of other people in the scientific community, the laymen. Like, it's just an experience that they should acquire and should remind themselves of. So to improve that, I guess offering them more support. If they have a bad day, give them that space to vent. If they find like they're struggling as instructors, perhaps improve and offer a course that will train them better to be that teaching fellow.
I'm wondering if you have any plans to share your findings with the School of Education and maybe have kind of an interdisciplinary approach to training.
That would actually be a great idea, especially because we do have a 2-credit course that is required by new lab assistants, learning assistants to take. So I definitely could bring my findings there, especially because our learning assistant program is expanding into more departments. So.
Combining a summer internship program like the Explo that would help the students break into.
So introducing it to the younger population of students, yeah.
More adapted to the environment when they get to the year.
Yeah. Okay, thank you guys.